In this video, we're going to learn the convention for naming ionic compounds. Ionic compounds derive their name from ions, which, as you know, are small charged particles. In this course, the compounds that you must be able to name will have only two elements. Later in the course, we will be learning the names of some clusters of atoms, and then you will be able to name compounds that contain those clusters as well. But for now, we're going to concentrate on our two-element compounds. When you are asked to name a compound, there is an important question that you must ask before you begin. That question is there a metal atom present? The presence or absence of a metal atom divides the compounds into their two groups, ionic compounds and covalent compounds. And the naming conventions for each group are different. So you must be sure that you have an ionic compound if you are going to use the ionic convention for naming it. You have a metal atom, you have an ionic compound. If you do not have a metal atom, you do not have an ionic compound, so you can't use ionic names. The ionic naming convention is not difficult. In fact, you already know an ionic compound, and I bet you already know its name. That compound is NaCl, common table salt, which we know as sodium chloride. So, let's see how it got this name. The first question we have to ask ourselves, of course, is always, is there a metal? Yes, sodium is a metal. And then the other one would be the nonmetal, chlorine. So what you see is that the metal kept its name in its entirety. The name of the metal goes first, just like you will see the metal atom represented first in the compound's formula. But in the case of the nonmetal, the ending of the nonmetal changed from INE to IDE. And that is the ionic naming convention. Let's see how it works with a different compound. This time we have CaCl2. The first thing we ask ourselves is there a metal? Yes, calcium is a metal. And so the first part of this compound's name is going to be calcium. And then the nonmetal is once again chlorine, which we learned from our last video changes the INE to chloride, to IDE, and so this compound is called calcium chloride. Now notice that this compound is called calcium chloride even though there are two atoms of chlorine. And our first example was called sodium chloride even though there was only one atom of chlorine present. So the numbers of atoms present has nothing to do with the ionic naming convention. The only thing that's important in the ionic naming convention is the name of the metal and the name of the nonmetal. Here's another example. K3N. Here we have 3 atoms of potassium and 1 atom of nitrogen. Is there a metal? Yes, potassium is a metal. And the nonmetal in this case is nitrogen. We haven't had nitrogen before, but we know what happens. The ending of the metal's name, in this case, ogen, becomes IDE, and we have nitride. So this compound's name is potassium nitride. Again, it doesn't matter that there are 3 atoms of potassium included in this compound, and later on you'll understand why. But for right now, it's important to remember that in the ionic naming convention, the only thing that matters are the names of the metal and the nonmetal. Let's try this one. SF6. So S is sulfur, and fluorine is a nonmetal, and that would be that would of course change to fluoride. You've probably heard of fluorides in your toothpaste, and that's what happens to change to make it possible to use the ionic naming convention. Now, is that really an ionic compound? It isn't. It's not ionic at all. We forgot to ask the first important question. Is there a metal present? No, there's no metal in this compound, and so this compound cannot be named with this convention. We made a big mistake. So let's finish strong with one more example. Aluminum oxide. And there I've given it away. I've said the name, aluminum oxide. And you should be familiar with that by now. Aluminum is the name of the metal, and oxygen is the name of the nonmetal, but to make it conform to the ionic naming convention, the end of the nonmetal's name is changed to IDE. And so this compound has the name aluminum oxide. And remember, it doesn't matter how many atoms of aluminum or how many atoms of oxide. It turns out that this compound can only come about if there are 2 atoms of aluminum and 3 atoms of oxygen. And later on you'll find out why. But for now, that's why the ionic naming convention is only concerned with the name of the metal and the name of the nonmetal changed to IDE. So what's our takeaway? The first thing is make sure there's a metal. And then secondly, use the metal's name with the IDE version of the nonmetal's name. If you follow this procedure, you'll be using the ionic naming convention properly. You might just want to remember our old friend sodium chloride as your mnemonic.